Hi everyone, in this video I'll be proving the quadratic formula. Alright, this particular question also came out in NECO 2025 this year. They were asked in one of the questions to this equation was given and done using quadratic, no, using completing the square method, derive the general formula, and then they were asked to use that formula to solve a quadratic equation. So we're going to prove that general formula A, and obviously this is a quadratic equation. And why is it a quadratic equation? It's a quadratic equation because the highest power of the unknown is 2, or you can also call it a degree 2 polynomial. Okay, so this is a quadratic function. Okay, so let's quickly prove that using completing the square method. And if you follow this video to the end, you would also be able to apply this same method, completing the square method, to solve every other quadratic equation. Okay, so simply start by moving this c to the other side, or your constant to the other side. So that will give us ax squared plus bx equals negative c. Okay, then what you do next is to divide through by the coefficient of of s squared, which is a. So dividing through by a gives us this over a. All right, and that will leave us with s squared here. S squared plus bx over a equals negative c over a. That's done. That's the first step done. Okay, the next step is to identify the coefficient of x. What's the coefficient of x? Positive b over a. What you do is to multiply the coefficient of x by half. So that will be b over 2 multiplying half. Then square that result and add up to both sides. So let's do that. So that will give us s squared plus bx over a. Now we're adding a new expression to both sides. That's b over 2a all squared. Okay, equals minus c over a plus b over 2a all squared. All right. So at this point, you just simplify the right hand side. That's this expression. This would give us negative c over a plus b squared over 2 square is 4, then a square is square. Then turn this expression right here to a single fraction. Maybe in one of my videos, I will explain how to find the LCM of algebraic expression. The LCM of a and 4a square is 4a square. All right. So if a divides 4a square, is going to leave us with 4a. Okay, because this a will take off one of the a's. And 4a multiplying negative c would give us negative 4ac plus 4a squared dividing 4a squared would give 1, and 1 multiplying this would give b squared. Okay, then you can just rewrite or rearrange to be b squared minus 4ac over 4a squared. All right, so let's bring down this expression. Now there's a simple arc here. Now all you need to do here is to identify x. Okay, the variable here, x, I'm leaving the square, x, and b over 2a all square. Now this is what I mean. You have x plus b over 2a all square. Now this works always for every kind of quadratic equation. Okay, if you expand this, you're going to get back this. So now when we have this, okay, we have two expression equating, to themselves, right? You have square here. All you need to do is to square root both sides so the squared can leave. Okay, so let's do that over here. Square rooting this, okay, and square rooting this. You introduce plus and minus y applying your square root. So this square will take away, this square root will take away this square, leaving us with x plus b over 2a equals plus or minus square root of b square minus 4ac over 2a. Okay, so now we can make x the subject of the formula right here. So x would be equal to negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. Okay, so in maths, if we have this, let's say 1 over 7 plus 3 over 7, if the denominators are the same, you can just add up the numerator and have it over 7. That's 4 over 7. So applying that here will give us negative b plus or minus square root of b squared minus 4ac all divided by 2a. And now we have the general formula, negative b plus or minus square root of b squared minus 4ac over 2a, and that's the quadratic formula. I hope you enjoyed the video. See you guys in my next video. Bye.